Okay, so today we're starting 6.7, which is the last section in chapter 6, and it's on recursively defined sequences. So our first one, vocab word, is an explicit rule. The explicit rule is the rules that we've already learned for both arithmetic and geometric sequences. So our arithmetic explicit rule was a sub n is equal to a sub 1 plus n minus 1 times d. Okay, so that was for arithmetic, and that was our explicit rule. We never learned the word explicit, but now you are attaching that new vocab word to an equation you've already learned. Your geometric one was a sub n is equal to a sub 1 times r to the n minus 1 power. So that was your geometric explicit rule. So today we're going to learn two recursive rules. The two recursive rules are down here for both arithmetic and geometric sequences. So it's a rule to define arithmetic and geometric sequences that gives the beginning terms of a sequence, and they're in a recursive equation that tells how the next term is found or how it relates to the preceding terms. When you're writing your recursive rule, you have two parts. So you're going to have to write the part that I have listed here, a sub n is equal to a sub n minus 1 plus d. You also have to state what your first term in the sequence was every single time. If you don't state what the first term in the sequence is, you can't be using this formula. So for both of these, you need to add that on, that you have to state as a separate equation what your first term was. So we already know what a sub n is. We've used that. We already know what d is. We already know what r is. The only new part to these equations is what a sub n minus 1 means. So a sub n minus 1 stands for the previous term. So if I'm looking for the fifth term, a sub n minus 1 would actually be 4, whatever our fourth term was. Okay. So it says to write the first 6 terms of the sequence. All right, so it's giving us the recursive rule. So it tells us the first term is negative 2, and then here's the part where it tells us what to do with it. It says take whatever your previous term was and multiply it by negative 2. So if my first term was negative 2, then it says to take negative 2, plug it right here, and multiply it by this negative 2. So negative 2 times negative 2 is 4. Then it says to take that term, so our 4 is now our next term, and multiply that by negative 2, which is negative 8. And then we multiply that by negative 2, which is positive 16. And we multiply that by negative 2, which is negative 32. In other words, it's saying, here's what you're doing every single time to get to the next term. So we started with our first term here. This is what we're doing every single time to get to the next term. Okay, and then you can graph them. We've already talked about graphing them. This would be the point 1, negative 2. This would be the point 2, 4. Then it'd be 3, negative 8, and so forth. Okay, so if we look at number 2, it tells us our first term is negative 4. That's what a sub 1 means. Okay, then it says, what do we do with it? Well, we take the term we already know, which is this one here, and we add 3 to it. So negative 4 plus 3 is negative 1. And then we're going to add 3 to that. So then we have 2. We're going to add 3 to that, and we have 5. So all this is doing is take the term you already know and add 3 to it. Then take that term and add 3 to it. Then take that term and add 3 to it. So try number 3. Okay, so we know our first term is 4. Then it says we're taking that term and we're multiplying it by 1.5. So our next one would be 6. Then our next one would be 9. We're multiplying that by 1.5, so we get 13.5. And we could keep going as far as we needed to. And again, if I'm graphing them, it's always 1 comma your first number, 2 comma your second number, 3 comma your third number, and so forth. So if they give you the recursive rule, what it does is it helps you find the next term and then the next term and the next term. The recursive rule is not helpful if you want to find the 100th term, unless you know the 99th term. And then you'd have to know the 98th term, and you'd have to know the 97th term, and you'd have to know the 96th term. So in other words, it's not going to be really helpful to find a number that's really far away in the sequence. But it's one that you were already using, whether you knew it or not. You were already using this when you were just listing the next 3 numbers. You identify the pattern and you continue that pattern out. This is just the formal way of saying continue that pattern to the next number. Okay. So the next section now, we are actually supposed to write the recursive rule. So you have to start by identifying what your first term is. So a sub 1 is equal to, in this case, it's 324. Then you're going to say to find the next term, which would be a sub n, what do you have to do? What's the pattern? So we need to identify the pattern. Well, to go from 324 to 108 to 36 to 12, we're dividing by 3, which is the same thing as multiplying by 1/3. So we know that this is going to be a multiplication pattern. So we're going to say that we're going to take 1/3 and multiply it by whatever the previous term was, which we say for the previous term is just a sub n minus 1. Both of these parts together are your recursive rule. You have to have both parts of it. So you have to identify what the first term is, and then from there you say, what do you do to that term to get to the next term? Well, you multiply it by 1/3. So try number 8. Okay, so I'm going to identify my first term. My first term is 9. And then I'm going to say, how do I find the next term? So a sub n is equal to, well, my pattern on this one is adding 5. So I'm going to say that I take whatever the term before it was, and I'm going to add 5 to it. And there is my recursive rule. Okay, number 9, it says to write the recursive rule for the sequence. So we're doing the same thing, only now it's just given to us as a list instead of in the table. So we start by identifying the first term. A sub 1 is equal to 3,125. How do I find the next term? Well, my pattern on this one is dividing by 5. Dividing by 5 is the same thing as multiplying by 1/5. So I'm going to take 1/5 times whatever my previous term was, which we say is just a sub n minus 1. It's saying it's the term before the one we're looking for. So if we're looking for a sub n, this is saying take a sub n minus 1, which means one term before the one we're looking for, and do this to it. Okay, try number 10 and number 11. Okay, so number 10, a sub 1 is equal to 8. You have to have that part. And then a sub n is equal to, well, my pattern on this one is multiplying by -3. So I'm going to take -3 times my previous term. Remember, whenever you think previous term, it's just a sub n minus 1. Number 11, try this one. A sub 1 is equal to 7, and a sub n is equal to, well, in this one, I am adding 6 each time. So let's take whatever the previous term was and add 6 to it. You can write it in the other order if you want to put it as 6 plus a sub n minus 1. That's the same thing. It doesn't make any difference. 12 and 13, again, it's the exact same thing. It doesn't matter if we're looking at it in table form, list form, or in graph form. Again, they're still giving us the exact same thing. All right, so let's move on to number 14. It says to write an explicit rule for the recursive rule. So they have given us the recursive rule. We need to write the explicit rule. Remember, the explicit rule is the rules that we've previously learned, the ones we already know. So I'm going to take a look at this one. It's multiplying by 3 right here. So I know that it is going to be a geometric sequence. Okay, geometric sequences for my explicit rule was a sub n is equal to a sub 1 times r to the n minus 1 power. So my rule would be my first term, which is 4, times my multiplication pattern, which is 3, and to the n minus 1 power. That's it. Try number 15 and number 16. Okay, so number 15, the rule is adding 11, so I know that that one is going to be arithmetic. My arithmetic rule was a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to my first term, which is 6, plus, and then it says we're adding 11 each time, so I'm just going to leave the n minus 1 part there, and then it's times 11. I can always simplify this if I want using the distributive property. So I'll distribute this here and here. So this would give me a sub n is equal to 6 plus 11n minus 11. And then if I combine my like terms, I can simplify it all the way. A sub n is equal to 11n plus 5. I'm actually okay with you leaving it here or here. I would give full credit for either one of those. But you can see it does look like a linear equation, y equals mx plus b. Okay, let's do one more like that. So it tells me the first term is -1, and then it's a multiplication pattern because it says I'm multiplying by 5, so that's going to be geometric. So a sub n is equal to my first term times my multiplication pattern to the n minus 1 power. And then I can always find whatever term I'm looking for when it tells me what number is for n. But now going the other direction. So now it's giving us the explicit rule, the rule that we've already learned, and we are supposed to write the recursive rule. So we need two things. We need our multiplication pattern and we need our first term. So to find our first term, all I need to do is plug in a 1 for n. So that means I'm looking for a sub 1. So 6 times 1 plus 2, which would give me 8. So my first term is 8. So I'm going to write a sub 1 is equal to 8. But then I need to figure out what the pattern is. So to find that, let's just find the next couple numbers in the list. So I know my first term is 8. To find the second term, I'd plug in a 2. So I'd be looking for a sub 2, which is 6 times 2 plus 2. So my second term would be 12 plus 2, which is 14. And then let's find the third one. Once we have 3, then we know for sure we can find the pattern. So that means I'm doing 6 times 3 plus 2, which is 18 plus 2, which means my third term is 20. So I go from 8, I said 20 and I wrote 18. So I go from 8 to 14 to 20, so each time I'm adding 6. So my rule is a sub 1 is equal to 8, and then to find a sub n, my next term, I am taking the term before it, a sub n minus 1, and adding 8 to it. You have to have both parts of this one to get full credit for it. Recursive rules, you have to have a sub 1 equals in your number. You can't just have a sub n equals in your equation. It was okay to do that and not have two parts for our rules we learned before, for our explicit rules, because a sub 1 was part of the equation. But nowhere in this part is there an a sub 1. So you have to know where the sequence starts. Okay. Try number 18 and number 19. So start by finding the first 3 terms. That'll help you find the pattern and a sub 1, and then you can write your equation. Okay, so on number 18, my first term, a sub 1, when I plug in a 1, 1 minus 1 is 0. So I have negative 3 to the 0 power, which is just 1. My second term would be when I plug in a 2. So 2 minus 1 is 1, so my exponent's 1. Negative 3 to the first power is just negative 3. If I plug in a 3, 3 minus 1 is 2. Negative 3 to the second power is 9. So now I can see that my multiplication is multiplying by negative 3. So I will write my equation. A sub 1 is equal to 1, and then a sub n is equal to my previous term times negative 3. So negative 3 times a sub n minus 1. Again, if you want to put parentheses around the negative 3, you can. You don't have to, but you do have to have both parts, the a sub 1 equals and the a sub n equals. And we'll try number 19. So again, finding the first 3 terms. So my a sub 1 would mean I'm doing negative 2 times 1, which is negative 2. Negative 2 plus 1 is negative 1. My second term would be when I'm plugging in a 2. So negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. And then my third term, plug in a 3. Negative 2 times 3 is negative 6. Negative 6 plus 1 is negative 5. So my formula is a sub 1 equals negative 1, and a sub n is equal to, well, each time I am subtracting 2. So that's arithmetic. So a sub n is equal to my a sub 1 plus my n minus 1 times my d, which is a negative 2. And again, if you want to simplify it, you can. If not, you can leave it like that. Oh, wait. Oh, I may catch my mistake. I just put it back in the same format we already started at. I did the explicit rule, so let me erase. This is not correct. Hopefully you guys are paying attention and caught that before I caught it myself. So a sub n is equal to, well, I'm taking the term before it, and I'm subtracting 2 from it. So a sub n minus 1 minus 2. And that is the recursive rule. We didn't need the explicit rule. We already had that one. Okay. Last section says to write the recursive rule for the special sequence. Ooh, special sequences. We're going to look at this in video 2. So come prepared to watch this and the last 3 problems in tomorrow's video.